So in today's video, we're going to expand our knowledge of classes, and we're going to talk about packages and access specifiers. Okay. The reason for this is that now that we know how to create a class in Java and methods and constructors, we should actually sort of start creating classes now. And to do that, what we want to do is we want to actually make sure that when we create a class, it belongs to a particular package or a particular let's get an example, right? If you are writing classes related to math functions, then you would want to package them together, right? Just so that you can kind of keep like concerns together, right? So let's get to it. Okay. There's some syntax here which we've actually glossed over and not really focused on in all the videos so far. The first one is this package syntax up here. Okay. So what is a package in Java, right? A package, you can think of a package just like any normal package of stuff that you would get, right? A package is a container for classes or data types or interfaces. We'll talk about those later, which are related in some way. So you would package up or organize code which is related to math functions in a package which is maybe a math com.example.math, right? So let's see. So when we created this project in IntelliJ, it created a default package for us, com.example, right? So what does this com.example mean, right? So actually what it means in the file system is this main class, which is a main.java file, is located. So I moused over it. So if you look at it here, you can see when I mouse over it, it's actually stored in source com example main.java. So if you forget everything before the com and just focus on the com.example, so in this case, right? So let me see if I can expand this. I can't. Let me see, like if I go to the directory path, right? So if I say directory path, you can see this whole path of everything up to where this example folder is. So this com.example, the dot means that there is a folder called com in your source directory. Inside this com directory, there is an example. So we can actually browse it over here. So I could show you, programs, IntelliJ, CodeOmelet. So there's a com directory. Inside that there's example, and in that there is a file called main.java, right? So this is one package, but this is just one package that the IDE created for us. There's no reason why we couldn't create our own packages, right? So let's go ahead and do that. So I'll right click on the source and I'll say new package, and I'll just give it a name. So I'm going to say com.example.people, right? Now this could be any name. Now what's happened is it's created another package within this com.example package. So if I actually right click on this, and earlier we had created a person class, so I'm going to create this person class in the com.example.people package, right? So again, if you were to browse the file system, you would see that it is under source com example people and person.java. So this file and the file in the IDE is exactly the same. Okay. Now when Java created, when the IDE created this class for us, it gave it this specifier known as, or access specifier known as public, right? So why did it do that? Okay. if you don't do this, so if you remove this, right, so Java comes with 4 specifiers by default. One is public, which you've just seen. The second one is private. The third one is protected. And the last one is known as default / package. Package private or package access modifier, right? So what does this mean? If you've noticed, whenever we've created, so let's go back to main, for example, right? Whenever you create a class, you can actually say that it can have some access specifier. Public means that classes or other data types within this com.example package and any other package can use this guy, right? So why does Java do this? This is for organization and for like what happens is, in many cases when you're creating much larger projects, what you'll see is sometimes you will create a class in a package which only other classes in the same package need to use, and no class outside of this package should use. So in that case, what you would do is you would leave out the public here. Okay, so let's actually do this with an example. So again, we'll say string name. This time I'll just create a small one. Now this should be familiar to you from last time. So I'm going to say string name. This dot name equals name. Okay, and notice for all of these, I've not put any specifier. When you're declaring a class, there are only 2 access specifiers you can use. One is public and the other one is not use anything, right? Whereas for these guys, which are attributes or functions, you can use public, you can use private, and we'll come to what that means. You can use protected, and this will cover when, so I won't do protected today. We'll do protected when we do what is known as inheritance later. And one is you can just leave it off, right? So like I was saying, in this case, you can just leave it off. And what this means is that if there is another class in this same package, aka the same folder structure, that class can access person, whereas any class outside it cannot access. So let's go to main and try to create a person, right? So let's say person. If you notice, Java did not give me an autocomplete for person. And when I typed out person, it actually tells me I cannot resolve this symbol. So this is Java speak or JDK speak for, I can't find the data type that you're referring to, right? So how do we get access to the data type, right? The way to get access to the data type is, one, we have to import the data type, right? The second, so let's try this. So let's say com.example dot, and now if you notice, there's no autocomplete for person, right? Because what has happened here is I've actually not put this class as public, meaning it's not available to anybody outside this folder people, right? So if there was another class, so let's do that as an example. Let's create another class. Let's say school. Okay. And let's give this school a person array. Right. Now, if you noticed, this compiles. So let me just remove this so that everything is fine. This code will compile. There's no errors or anything like that. So I can access a person data type here because school and person are in the same package, right? School is public. Therefore, I should be able to access school here. So if you notice this, right? So Java, the IDE did a few things for you. One is it created this import statement, which is com.example.people.school, and now I can create variables of the school type, right? And now if you remember, we spoke about this thing called a default constructor, which is a constructor which takes no arguments. I've not created a constructor here, which means that the Java, the IDE or the Java JDK, the Java environment has created this constructor for me, right? So this code should actually compile fine. There should actually not be any problems over here, right? So that is what it means when we are talking about access modifiers. It literally means who has access to it, and the person who creates classes can determine who can access what, right? Just by doing simple things, by making things public, right? So now that this person is public, we could actually create a person as well. So if you notice, the ID is now giving me an autocomplete. So I could say new person. I can either create the person this way, but if you notice, there's an error here, right? So just a revision, this constructor, so if you notice this person thing here, when I moused over it, it says person constructor, which takes a string as an argument, is not public. So the IDE is giving you some hints that while your class is public, you still can't construct it because this guy is not public. So to change it, all I have to do is make this guy public, right? And now this works. So I could actually say new person ABC for its name, right? When you are creating your classes, right, one thing to remember is you should actually protect access to your characteristics of your class. And a very good reason is the following when we do this, right? So now that we've introduced access control, we can talk about it. So int age, okay? What I'm going to do is I'm going to make both of these guys private, okay? So name int age, this dot age is equal to age, okay? Now one fancy thing that the IDE can do for you is if you right click it, okay, and you say generate, it will generate what is known as getter and setters for both of the properties or characteristics you have in your class automatically. This is stuff that we could have written by hand, but the IDE is actually doing it for us, okay? If you notice now, while looking at the function header, it has an access specifier which is public. This means that a class which is declared outside of our package, that means outside of the people package, can access these functions, right? So let me just complete this and let's say I do this, right? So I can say sout p dot name, sorry, get name is equal to p dot get name. And similarly, I could now print out the age, p dot get age is equal to p dot get age, right? So let's run this code and see what happens. And so now you've got the values for the name and the age of this person object that's in memory, right? Now, why did I say in the beginning that you should protect access to these members, right? Because age is this age function is a perfect example. When you want to set the age, you want to actually say if age is less than 0, which means it's negative, right? Then just return. Else you can set the age, right? So this is a good way of protecting your class against some, really bad mistakes that someone could make. So for example, I could say p dot set age and I could give it a number of -10, right? And now I could actually print this out after the change. And let's see what happens. It shouldn't change the age at all. The age should remain 20. Okay. However, if I change it to a +10, and I run this. Now if you note, the age of that person object has been changed to 10, right? So this happened because now if I want to actually change the age without doing this check, I can't do it because I can't say p.age equals something, right? But if I'd made these properties, let's do it only for the age. If I'd removed this, so if I'd said made it public, for example, right? Let's see what happens here. I could say p.age equals -10. Okay, now let's run this. And if you notice, the wrong age got set here. A negative number got set here, which should never ever happen for the data model that we are using for a person. A person's age should never be negative, right? So this is why you don't really ever want to do this. You should make your properties private as much as possible. So let's do it the right way now. Okay. And if you want to change these properties, you should create functions and then make sure you are using the right invariants. Invariant is a fancy term for saying, you make sure that when you're setting this, it means the right thing, right? So make sure you're doing those checks in your functions, and then you can now safely access your properties from outside your person class in some other class, right? So just to rehash, when you're declaring a class in the header, you can only put public or you can leave it out, right? So let's try private. You notice there's an error, and if you try protected, there's an error. In fact, by the way, I encourage you guys to actually try these kinds of things yourself, right? Because when you're doing it in an IDE, you've got someone looking over your shoulder and it kind of helps you out. Now here, if you notice, I can actually do these things. So in fact, in this case, because person is part of the people package, I could actually possibly remove this. Let me try that. If I remove these, right, I told you the default access is package private, right? So if I say p.age, if you notice, I don't get the value now over here because main, which is another class in the package com.example, cannot see it. And I think it will make it more easy if you can look at it from the point of view of the file structure, right? All the classes in this folder, that is com.example, cannot access classes in this folder unless you give it access by saying this is public and this is public. But it doesn't really end there. It's not just enough to make person public. You then have to make some of its functions public, its constructor public, some of the properties, which we agreed is not a great idea, to make them public if you need to for some particular reason, right? In my case, I always prefer to make these guys private. So this covers packages, right? And this covers access modifiers, which is public, private, and the default access modifier, which is this, right? So the moment I do this, if you go here again, you'll see person is not accessible. There's an error. It's in red, right? It says this is not public. You can make it public by quickly just clicking on this shortcut. So I could say public, and then if you go back to the source code file, the IDE would have done this for you. So this is about packages and access control. So now we have a way of controlling access to the classes we create, right? So when you're working in a team, there might be certain classes that you create which you don't want other team members to have access to. And in that case, you can make them package private by removing this. And then what that means is that those classes are actually really used for the functioning of your own public classes in your own package. Okay, so that covers packages and access modifiers. The one access modifier that we didn't talk about was protected, and that we can only talk about once we reach, for example, inheritance. in one way we could actually do this. So we could say protected void test as out called from another class in the same package, right? And go to school, and we could just create a function here which says public void call person test. And all this does is I'm going to just create a person here. P is equal to new person okay, and I'm going to say P dot. If you notice, the test function is also callable even though it is a protected one, right? So the protected access means that if it's protected, you can actually call this function. So in fact, let's do this. So I'm going to say school s dot call person test, run this code, right? So if you can see, it says here called from another class in the same package, right? Which is this function getting called, sorry, here, which is protected, right? So protected means two things. Any other class in the same package can call it, and the second meaning can only be explained when we do inheritance. So that's it for this video, and we'll see about inheritance in a future one. Okay, thank you.